Hi, welcome to the third session of iOS development training. Uh, in this session, we will be looking into some advanced concept of Swift language, optional tuples and all other things as shown here. Yeah, so let's get started with optionals. So basically, optional value can contain a value or it can be null. Means it can't contain any value. So uh, these are basically used to handle the null values, the null for null checking, and to avoid crashes which happens on runtime. Okay, so we generally use a question mark to declare an optional value. So uh, let's see how can we do that. Okay, so we're back to the playground. Generally, we have seen like a declaration of a variable or a constant like where uh, some variable, let's say of type int. So we can declare like this. Okay, variable. What if we don't have a default value? So we can declare like this. Okay. So basically, in your code, you if you if you are receiving a data from server, or let's say if the value of some variable is currently not available, and later there are chances like in some cases it can be available or in cases it cannot be available. For example, we have a function over here, calculate value. Okay, so what this function does is, here is another variable where is available equal to true. Okay, so for example, let's consider we have a variable, a boolean value. So default value is true, but later it could change in the program. In later stages it can be changed to false, or it can be true only. Okay, so here we have a condition, if is available equal to true, comma, this somewhere this somewhere will be uh, 10. Okay, else somewhere will be else, there is no else bug, somewhere will be nothing. Okay, so in this case, if you are printing that somewhere. Okay, so let's consider if is available is true, then it will have a value. But if it available is false, is false, then what it will happen is, so here is a chance of getting crashed. This is still running, building. So it will get crashed because here we haven't provided any default value, and here also it will be not going inside this block, so this value will not be get assigned, so it will be get crashed. Okay, still running. let me close this and again open. You can see here the error also is coming like coercion of implicitly unwrappable value of type int. There's a question mark, you know, to any. So it's basically throwing an warning here. Okay, so you can see, it print as nil. Okay, here. Okay, because it don't have value. In this case, what happens? Generally, app gets crashed here because it's an null value. So app gets crashed. So to avoid like these conditions, what we will do is in this case, we will mark this as an optional. If add question mark beside its data type, so that property or that variable is become an optional. Okay, so now if you try to uh, do without instead of printing, if you are looking at let's say let value equal to somewhere, if you say this is the int. Okay, so now here it will throw an error because what we are doing, we have taken value as a int, not an optional int. Okay, only int, and we are assigning this somewhere which is an optional int. What did it say? Value of optional type int must be unwrapped to a value of type int. You have taken this an optional. Now you have to uh, take the its primitive type of its. You have to uh, take the int out of this optional int. Okay, so that value, that process is called unwrapping. Okay, so not only property declarations, if you have a function which returns optional. Okay, so let's take a name of function as return optional. Okay, so it has arguments, it returns optional value. Okay, optional integer, it returns an optional integer. Okay, so let's add here return 10. Okay, so now if you again look into let value int, you want to int value. Okay, that's why you are specifying value as a int. Okay, value int equal to, if you call this function returns optional. Okay, so here also it will throw the same error. Value of optional type int must be unwrapped to a value of type int. It says like unwrap int optional to integer, optional integer to integer. Okay, so uh, this is the declaration of optional other things. So we will next we'll be looking around what is this unwrapping called, process of unwrapping. So let's go to optional unwrapping. So basically optional unwrapping, as said, is the process of casting optional values to its primitive data type. from optional integer to integer, from optional string to string. Okay. Okay. So it can be unwrapped in many, many ways. Some of these are, first one is force unwrapping. uh, this force unwrapping is not recommended one uh, for many cases. Okay, we will look into that why it's not recommended. Second one is using if statement, and third one is optional binding. So again, in optional binding there are types, so we'll be looking into them when we are going to optional binding. Okay, so let's see what is a force unwrap. Okay, let's say you are assigning value here somewhere. Okay, so it's throwing error. What is force unwrapping is, generally force unwrapping means forcefully unwrapping that value, means forcefully taking the primitive data type of that value. Means if it's an optional integer, you are forcefully considering the integer value of it. Okay, forcefully converting it to, so that force unwrap process done by using exclamatory mark. Okay, if I use the force unwrap, let's see what it will happen. So error. So this is the called crash. Okay, so it's crash because it doesn't have any value. Okay, and if you make it true, then it will have a value of 10, right? If you run this, oh, we have to call this function actually. Yeah. So if you see, it is true, so its value becoming 10. Okay, so this is the when it was false, so it was crashing. See, it is crashing when it was false. So unwrapping, force unwrapping, it gives you a value if value is present in optional. Okay, but in case if there is no value in optional, it's null, then again it will get crashed. It can't provide you a safe way to unwrap an optional. So uh, so this is not mostly recommended. In some cases it can be useful. Okay, so next one was our if condition. Okay, using if statement. So how in if statement we can do is, let's print that value over here. Use if somewhere not equal to nil. Okay, we said like optional can have value or it can be null, right? So what you are doing is we are checking if it's null or not. So it's not equal to nil means it's not nil, it have value. So simply print that here. Okay, else print value is nil. Okay, so uh, let's say what it happened, it's a false, so it should print value is nil, but it will crash here. Let's comment out here. See, it's printing value is nil because it has null value. Okay, and if you print true, so it's a simple if statement, simple if condition. We are checking if it has a value or not. Okay, so this is the another way of unwrapping. Then there is another way called optional binding. Okay, so optional binding means uh, binding means what it says is the process of uh, unwrapping and value. Okay, and unwrapping an optional. Okay, plus getting its value in another variable or constant. Okay, this whole process is called unwrapping. So we can do that using uh, if let statement, if let, or another one is guard let. So we previously we have seen what is if statement and what is guard statement. Okay, so now here what we are doing is we are combining if and let. So generally let is used to declare a variable, sorry, declare a constant, not variable. Yeah, and if is a condition. So here what we are doing is we are we are checking a condition in itself, in condition itself we are also declaring a value. Okay, same goes to guard also. So guard is also condition, again we are declaring a value. So that process is called optional binding, unwrapping plus getting a value, storing a value inside one variable or constant. Okay, so let's say let's take an if let. So this condition I can rewrite like uh, if let value equal to somewhere. Okay, here uh, there will be else block also. Okay, here this is the if it statement is true, so this is the closure to be excluded. Okay, if not, this else one excluded. So what here is happening is I am I am what doing, I am checking that this somewhere optional contains an value or not. If contains a value, that value will be the unwrapped version of that value will be stored into this this property called value. Okay, this constant called value. Okay, if not, if this is null, then it will go to else block. Okay, so let's check how it works. Value is null. Okay, so see, it printed a value of 10. Okay, I was printing that value, as it's true it will be 10, right? Or otherwise if I make it a false, so it will print value is nil. Okay, so in the same line, in the same line we are unwrapping an optional and storing its value in a constant. Same wise, if you have to modify this one, let's say if you have to add some value to this. Okay, and then perform this operation. Okay, so will you be able to do this? No, because it's throwing an error. Left side of mutating operand is immutable because value is a let constant. So constants we can't change. In that condition, you can use where also here, if let or if where. Purpose is same, the only difference is this will become mutable. You will be able to change that. Okay, so there is the same line of code being used here also, and same line of code is being used here also. The difference is it has two things, like storing a value by unwrapping it. It only checks it is null or not. Then again, if you can't it's throwing an warning here from int to any optional to. In this case, if to avoid this warning, what you have to do is, let's say this is true. Okay, let's see what it's printing there. It's printing see optional of 10. We just want 10, right? So in this case, what you will do, you have checked it's not null. Okay, here. So here you can use force unwrapping. Now it will won't get crashed because we already had a check here if it's null or not, right? So if you look, if you run, see it's printing a 10. Okay, in this cases you should use force unwrapping. After checking if it's null or not, if it's had value or not, you can use force unwrap. But before checking, using force unwrapping is not recommended. It can result into a crash. Okay. Similarly, a guardlet. It's so what is the difference between if statement and guard statement? So as per we saw in previous sessions, so if statement, if the if the condition gets satisfied, so the closure, it will be accessible in this closure only if it's true, or it will go to else. But guard has this else first, then after the whole guard statement, you can access that you can use that value here. So else blocks comes first for guard statement. Okay. So let's see. Same value equal to somewhere. So here guard statement needs else block in the statement itself. Okay. Else. So else means if that's not have value, that's a nil. In this case, value is nil. Okay. Now after this condition, you have to mention return also here, so that it can skip this part. Okay. This part it can skip, because this part only runs when this value is not nil. See, the value, this value is accessible beneath also. Okay. What it says. So uh, there's no comma. Let's add, see, this if you are mentioning return, what it say, return invalid outside of a function. Guard statement needs a scope here to return, what it will return here. It's a playground, so that's why this issue is coming here. So if you write this in a function, let's say unwrap is the name for function. So if you do like this here, then it accepts. Why? Because this return, what it will do is, it will return this context itself. It will come out of this concept context. Okay. If it goes to else block, or this this block will be get executed, this context will be executed, means the function will continue its execution beyond guard statement only if that guard statement is get satisfied. Otherwise it will uh, it will return this whole context. Okay. So that's the guard statement. Let's call that unwrap function here, so that this code can get executed. Okay. So it's printing 10, means it has a value, and that value has been print over hit here. Okay. So that's called optional binding. Okay, unwrapping itself has a binding, and binding means unwrapping plus storing a value in a constant or variable. Okay, similarly, here we have used var. A guard also you can use var. You can change that here. You know, you can do like this also. This value is this value. Okay, so that's the optional binding, and that was about the optionals. Okay, so the next one is tuples. So, okay, tuples are, it's a group of multiple values. Let's say two or three or four. It's a group of values. Okay, that values does not need to be a same type of same type. Means if you are taking a tuple, it can have a group of integer and string. It can have bool also. So this combined group is become a one type called tuple. Okay, so. Let's see how we can do a tuples. Okay, so tuples are declared like this. Let's say where some tuple. Okay, so tuple is also if you are declaring, so tuple will can be considered as variable or constant. Okay, so after this variable declaration, we should uh, specify a type here, right? So the tuples are as we said, it's a group. So it will be a open and close parenthesis. Let's say this tuple contains one integer and one string. Okay, so this is the declaration of tuple. Okay, and like this you can declare like this, or you can make it optional also, like other data types like integer and strings. So tuples are also almost same as the another data type which contains the predefined data types, a group of predefined data types, integer or string, or integers itself. Yeah, if more than one. Tuple is means more than one. Okay, or int string. Let's say boolean. Okay, so let's say you have to you can declare like this optional, or you can directly uh, assign values here. So first one is int, let's int, second one also int, then it's a string. Okay, then boolean, so true. Okay, so we have declared a tuple with its initial values or default values. Okay, let's say you have to in after some time you have to change the value of any of this. Okay, so let's say I have to make this 100. So you how can I do is some tuple dot synopsis. Okay, so 0 1 2 3, here you can see 0 1 2 3. So 0 means zeroth index. It's kind of zeroth index. So at zero index we have this value. Okay, 10. This one is the zero. This one is the one. This one is the two. This one is the three. Okay. If you have to change the value at first index, what you will do is dot zero equal to 100. Okay. So that value will be changed. And if you print this some tuple over here, let's see what will it will print. See, the value has been changed. 100, 20, high, true. Okay, similarly if we have to uh, print any of these ones. Okay, Let's say if you have to print this string hi, it's in the third place, means the order will be the index will be 2, 0, 1, 2. Okay, third means 2. So uh, you can say like print some tuple dot 2. So it will print string. Okay. In previous session we have discussed about type interference. We said like Swift automatically interpret the type of variable if you want to mention. So let's say this sum tuple of 2 is a string. Okay, but what we are doing is we are considering let a new constant. Okay, new constant. We are not defining any type here. Okay, we are just saying some tuple of 2. Okay, so if we can see here is some string. So so compiler tells us that this is a string. Okay, we haven't specified the type here, but again it it's in intellectual language. So it's considering it as a string because you have typed a string. So this is another example of type interference feature of Swift. Okay, means it avoids errors at uh, compiler time only. Compiler itself saying it's interpreting the type, so that will result into type shape language. Okay, so these are tuple. Also you can specify this tuple in function as a parameter. Okay, let's say you have a function with tuple. Okay, so so function as a parameter of uh, let's say a, consider it as a, it's an integer. Okay, and there's another parameter b, which is tuple. Okay, or let's say uh, b as a int, then c. Okay, so this is accepting it as a tuple. Okay, when you call this function in your code, sorry, function with tuple, right? Function with tuple. See, what it asking? A is integer, it needs integer. B also integer, it's saying that give me integer. Okay, we are giving integer, but in C it's asking for a tuple of integers. Okay, so here what you will do is, so you will give that a tuple, then comma 10. Okay, that's acceptable. So you can pass a tuple in for function also. Okay, also your function can repeat a tuple also. Function returns tuple. Okay, let's say you are passing some values over here, and what this function will do is, this function will send a tuple of those values. Okay, see here the return type for this function is tuple. Okay, so here simply you can return tuple of a comma b. Okay, so if you call this function, it's returning it. The function has some return type, so basically you have to save the result of that function. Okay, so let's say return value we are storing there, and calling function returns tuple. I'm giving a value it a 10 of 20. Okay, so let's see what this return value will be. See, it's tuple of 2010. Okay, so this about tuple. Also, as we said, this index dot index syntax. Okay, we can do other thing also. Instead of that, we can give argument names for tuples. Like let tuple equal to value 1, 10, comma value 2, 20. Okay, so here I directly declare a tuple without giving its data type. Okay, we can do like that also, as shift interpreters its type. Okay, so if you want to if you have given a name for this argument. Okay, first one, second one. Okay, so now you can simply access that as tuple dot value 1 instead of index. Okay, print tuple dot value 2. Okay, you can do like this also. You can specify first the argument name, and then a value, right? Or if you have to you have to declare a type. In type itself, you can declare this arguments also. Value 1 of integer type, then value 2 of again integer type. Just remove here these things. Okay, so this is also acceptable. See, okay, so that was about tuples. Okay, so tuples is a group of multiple values that can be of different types also. So next one is lazy properties. Okay, so we have seen properties. Okay, different types of properties also, like stored properties or computed properties. So another one is shifts. Another one important feature is interesting feature is lazy property. A lazy property, it's a not a stored property, computed property. Okay, it will compute its value, or stored property also, it can be stored property also. Okay, it can be both. So a lazy property, its value will be its value will be calculated at the not at the declaration, at time of declaration. It will be calculated when it will be used for first time. Till then it will not get initialized also, it's not initialized in the memory also. Okay, if it's been used later it at any stage, then only it will be get initialized, otherwise it will not get initialized. Okay, so we define a lazy property by using lazy keyword. Okay, let's see uh, how we can declare a lazy property. Okay, so we said we can declare lazy property using lazy keyword. Okay, so let's see lazy, some lazy property. Okay, I'm specifying a type for it as int equal to, okay. So uh, I want, this property to be using this tuple, okay, the tuple we are declared. So what we'll do is return tuple dot value 1 plus tuple dot value 2, okay. Oh, it we have to give a var. Fine. Okay. uh, it says like this is already a global variable, so you can so get global variables we can use, right? Or simply you can say return a 10 plus 10 here, okay. What it's saying, maybe it should need a class. Let's say class person, okay. If we are declaring here, okay. So you can declare like this also, okay. See, lazy where some lazy property int equal 10. So when this will be initialized into memory, this will not initialize immediately. These properties will be initialized immediately into the memory, this tuple or this return value, okay. This will be initialized into memory with immediate, okay. But this will not get initialized into memory. When this will initialize, after some performing some operations over all over here, and when at some time if you have a if condition, if we have taken a bull, I guess here is available, right? So if is available, you are checking, if it's available, then only you are accessing this. It needs a class. It's not initialized in playgrounds. Everything doesn't work on playground, okay. Let's consider our here only, where is used equal to true, okay. Let's say you are accessing over here, print some lazy property, okay. Let's say after all this stuff, after all doing the some stuff, you are checking like, if it's used, then only you are accessing that property for the first time. You are using that property for the first time, okay. So at this point, at this point only, this will get initialized into the memory. Okay, otherwise it will not get initialized into memory. So this is called the lazy property. Okay, we generally use lazy properties in many cases. If we are not sure, like this will have its use in next case. So instead of loading it's into memory very first time during declaration, so we do that later. Okay, so that was the lazy property. It's in the function. Okay, so that was a lazy property. So next one is here, uh, closures. Okay, so closures are, these are the special type of a function only, functions, but without a name. Okay, so coming to definition, closures are self-contained block of functionality, or let's say self-contained block of code, which can be, passed over the functions or using anything or around your code. Okay, so that is a block of code which can be used or passed at some from some place to another place. Okay, that thing is called closures. So the let's see what is the closure definition. So as we said, it's very similar to function without function name, right? So what function has open and closed curly brace for its function word, right? So here closer closer takes arguments, and it has some return type also. Can add from here also, closer expression. So if you look into this, it's get added only here. So let's add from here. We can see the closer expression. You can see, it's similar to function. It doesn't have a name. Okay, so it has parameter and return type. Okay, additionally it has, this in keyword, and beneath this there are statements. Okay, so let's add it here. Let's say we have here, uh, integer type, return type is also integer. Okay, print a. So these are the values closer needs, and this is the return type it returns. Okay, so there are two values. So this is the declaration of closer, right? Here you have some blocks of code. So again, this playground says let my closer equal to. Okay, now it will. The playground throws certain errors. Let's open our Xcode project. Let's declare that closer here. I'm saying return type is, see here it's accepting. So playground has some issue. So this is the closer. Okay, so we can declare closer as a property also. So this some closer is a property which is a type of closer. Okay, so when we are using this closer, let's say we are using this function. Struct. Automatic restart. Hello, hello. So this, okay, system has been struck down here.